Okay, I want to re-practice these problems with you just to give you an example. I'm going to go over the first two of each one, and we'll show you, we'll start with Boyle's Law, and I will resize it here. We'll talk about Boyle's Law. Remember that Boyle's Law it explains the relationship between pressure and volume of the equation that represents Boyle's Law that we use most often is pressure before times volume before is equal to pressure after times volume after. So remember, on both sides of the equation, the one on the left side is before and the right side is after. We'll solve out number one, and I'll circle some important things that you need to make sure you understand when you're solving these problems. You need to be able to know the before and the after and how to recognize them apart. Generally, the before is in the first part of the word problem and the after is in the last part, but I'll circle them as we go just so you can understand. Okay, number one says a warning signal. Number one's here. Number one says a warning signal horn holds 2 liters of air at atmospheric pressure and is compressed into the 0.45 liter canister. If its temperature remains constant, what is the pressure of the compressed air? So first thing we need to do is we need to find what's it before, so we can write that down in the equation. Sometimes you'll be solving for before, and sometimes you solve for after, but we need to spot which values you need to put your numbers here. So first of all, if the horn holds 2 liters, we're going to consider that as before. So we would that would be volume. So we're going to write over here where we would put volume. We're going to write 2 liters. And I'm going to close parentheses. Now that's volume. The next thing it says is atmospheric pressure, and I'll circle the 2 liters so you know. 2 liters. And the next thing it says is atmospheric pressure. Well, when we talk about atmospheric pressure, normal atmospheric pressure is 1 atmosphere, 1 atm. So we will fill that section in over here. The initial pressure will be 1 atm. So now we pretty much self-explain the before pressure. And then it says here it's compressed into the 0.45 liter canister. So if you look right here, 0.45 liter, that's going to be an after, and that's volume. And that's going to go over here on this section. The question's asking, you might want to do this when you solve these problems, is you want to circle what the question's asking for. And the question is, what is the pressure? So I'll write that we don't know the pressure. So I'm going to put my equal sign, and then I'm going to put pressure 2 because we don't know it. And then I'm going to list my volume, which was parentheses 0.45 liters. And so how do I solve this out? Well, solve this out pretty easy. I take 1 times 2. I do this side first. 1 times 2 is 2, is equal to my final pressure times 0.45 liters. And so I need to get this by itself so I can solve the final pressure. And my final pressure, so if you want to divide out by 0.45, divide this by 0.45, and you're going to end up with 4.4 if I use of a round to my absolute value here, or my significant figure, sorry. You're going to get 4.44 is equal to your pressure 2, or your final pressure, and that is at atmospheres, 4.44 atm. And that's how you would solve for number 1. So now I want to quickly work through number 2. I'm not going to explain as fast, or slow, sorry. Try to speed the things up so you can get on to Charles' Law. On number 2 it says bacteria produces methane gas in sewage treatment plants. This gas has been burned or captured. if a culture produces 75 milliliters of methane gas at 700 millimeters of mercury, what volume would be produced at 770 millimeters of mercury? So we're actually trying to solve for volume, and we're trying to solve for the final volume. So if I quickly set my problem up here, my initial volume I'm going to call 75 milliliters. As long as they're both in the same units, it's okay. You can still use milliliters. Milliliters is a unit of gas. It's just a little smaller. Like I said, it's smaller than, it's in the thousandth of a liter. So milliliters is still fine. Your answer has to be expressed though in milliliters when you get your answer. All right, quickly doing that. So we have my volume, and we have pressure. And it doesn't really matter which side you put it on. We will move this, and I'll go ahead and move this over. There we go. 75 milliliters, and we need to look at our initial pressure, which our initial pressure here is 700 millimeters of mercury. So I will put 700 mmHg. So these two numbers are going to multiply times each other, and then that's going to equal our final pressure times our final volume. And our final pressure is 770 mmHg times, and I'll have to write this down here, times our volume 2, and this is what we're solving for. So if I write this out a little bit, move this over, write this out here, it's 7, so what I'm going to initially do is I'm going to take 700 times 75 is equal to 770 times, I'll just put it in parentheses, times my final volume. And I'm going to solve for my final volume. I'm going to take 700 times 75, and it's going to be 52,500. And I'm going to place that as equal to 770 times V2, and that's times. So I want to divide out by 770 on this side, and divide here by 770 on this side. 770 cancels out, and I'm left with my answer. So 52,500 divided by 770 is equal to 68.18. And we're solving for volume, and we expressed it in milliliters, which is right up here. So our volume here is expressed in milliliters. And that's how you solve out another Boyle's Law problem. Okay, I'll let you solve on your own number 3, and you'll need to turn that into your sub. But we need to go on and do the Charles Law problems, and I'm going to do the first Charles Law problem and let you do the final 2 Charles Law problems. Charles Law is a relationship with gases between temperature and volume. And so when we talk about that, we express it in the equation volume 1 divided by temperature 1 is equal to the volume 2 divided by temperature 2. So what we have to do here is we have to identify our volume before and temperature before, and we have to also then identify our volume after and our temperature after. So to do this, very easy, I'll read the first question here. First question says, a balloon is filled with 3 liters of helium at 330 degrees Kelvin. Now remember, I want to remind you that Kelvin, when we talk about Kelvin, Kelvin is a temperature, and it's a same scale as Celsius. Celsius and Kelvin are on the same scale, but they're not equal. They're on a different range. And like I told you yesterday, when it is 0 degrees Celsius, it's actually 273 degrees Kelvin. And for a lot of purposes, not to go into in depth, it has to do with absolute zero, and that 0 degrees Kelvin is actually negative 273 degrees Kelvin. But anyway, for our purposes, all you need to know is that Kelvin is a temperature. And so when we talk about Kelvin and we describe it, you have to understand that Kelvin is definitely a temperature, and we have to list it as a temperature. It actually doesn't matter. It doesn't matter that it is not listed as Celsius or Fahrenheit or anything. You're going to plug it in the equation. You're going to solve it. As long as you have Kelvin there, it's okay. Anyway, moving on, we're going to look here, and I'm going to, again, write the equation up here. Volume 1, right, temperature 1, is equal to the volume 2 divided by temperature 2. Okay, we need to solve this. It says a balloon is filled with 3 liters of helium at 330 degrees Kelvin at 1 atmosphere. We're not concerned with really atmosphere here because it's pressure. We're doing Charles' law. And so you're given here, we're given volume and we're given temperature. And this is initial, so we're going to put that here. We're going to put 3.0 liters on top and divided by 330 degrees Kelvin. We're going to draw an equal sign. And then we're going to set the other side up. It says the balloon is placed in an oven where the temperature reaches 340 degrees Kelvin. What's the new volume? So we know here we're solving for volume. So I'll put the new volume here on top. That's what we're looking for. And we already know our second and final temperature, which is 340 degrees Kelvin. Alright, we're going to solve this just like any other algebra problem. We're going to divide 3 here by 330 degrees, and that will be 0.009. And then we're going to put that equal to V squared, and we're going to divide that by 340. Okay, so we need to, it's not squared, I'm sorry, that's not squared. That's the second volume, that's the final volume here. So what we're going to do is we're going to solve for this final volume. And you're just going to use algebra. You're going to multiply this side out by 340. So in other words, we're going to move 340 over here. So it's 0.009 times 340 is equal to our final volume. So in the calculator, when we plug that in, we're going to end up getting 3.09. Because we're solving for liters, that's our final volume is 3.09 liters. So we actually went up just a little bit in volume, and that would be the truth because we slightly increased the temperature. Okay, I want you to set the other two problems up, number 2 and number 3. Set those up just how we set these up and solve using that equation. V1 divided by T1 is equal to V2 divided by T2. Solve those and turn those in with your other problem from Boyle's Law into the sub by the end of class. You'll find these problems also in your Shobi folder that I signed yesterday. If you log into Shobi into your account, you can practice from there. Make sure you write your answers down on a sheet of paper. Put your name on them and turn it into the sub. Then the next thing I want you to do is I want you to open up the practice problems continued. I think it's the calculations, more calculations, and I want you to turn some in. I'll show you that sheet right now. Alright, the final thing I want you to do is I want you to practice 2 problems for right now. Actually 3 problems, and I'll circle the ones I want you to do. I want you to do number 1. I want you to do number 2. And then I want you to do number 8. So number 1, number 2, and number 8. You'll have to apply one or the other gas law problems. Remember, the others don't do 3, 4, 5, 6, 7, 9. Just do 1, 2, and 8. We'll do the other practice later with the other equations that we're going to learn and I'm going to introduce on Friday. But I want you to practice with number 1, 2, and 8. If you would, turn those in with your other practice problems on your sheet that you turn into the sub at the end of the period. Remember that there's 2 different equations here that you may be using. You just got to figure out which one you're going to be using. The first one is Boyle's law, which is pressure 1 times volume 1, that's before, is equal to the pressure after times the volume after. That's Boyle's law. And then Charles' law, you're going to be using volume 1 divided by the initial temperature is equal to the final volume times the final temperature. So either one, whichever one applies to the problem, you'll have to spot that. If you're going to use being pressure and volume, you're going to be using Boyle's law. If you're going to use volume and temperature, you're going to use Charles' law. So what I want you to do is do 1, 2, and 8 on a sheet of paper, the one that you did your other problems with, and turn those into the sub at the end of the period. After you're finished with that, you may stay on the iPads, but the iPads need to be turned in and plugged back in to at the end of the period.